has 10 in the j direction plus 1 in the k direction, right? So those are our two vectors that are created. So now I want to find the angle between these two vectors. So first thing I need to do is I want to find the dot product. So if we do the dot product, what value are we going to get? Yeah, so the first piece is going to be 0 plus the second piece is 0 plus the last piece, which is 2. So you get 2. So the work on this, now, it may be helpful for you to take these and convert them to coordinate form so you can see. So the first one is going to be 10, 0, 2. Whereas the second one is going to be 0, 10, 1. So when we multiply the first ones together, this is why it's 0. Second pieces together, this is why that's 0. Third pieces together, this is why that's 2. Okay. That makes sense, everyone? Okay, so we know what the dot product is. All right, so the next thing I'm going to do is I want to find the magnitude of vector v, and I need to find the magnitude of vector u. So what would be the magnitude of vector v? And don't worry about simplifying it, just giving what it would be. Yeah, and which is, I think it's going to be the square root of 104. All right. Then the magnitude of vector u is going to be what? The square root of 101. Okay. So we know that theta is going to be the cosine inverse of the dot product, which we said was 2, over the magnitude of each. So square root of 104, square root of 101. Okay. So now in this particular problem, since it's an application, it makes more sense if we do it as a do it in degrees instead of radians. Okay, so if you do this calculation, what value do you get? Yes, you're going to get 88.88 degrees. So that is the angle that is to that. Now, it looks like it, if I did a better job in my drawing, it would look like it would be 90 degrees. But it really isn't 90 degrees. Okay, it's actually a little less than 90 degrees. And that's just because of how the grade works. Okay. Any questions? So we have to be careful with this particular problem in that we have to the reason why we're able to do this the way it is because they gave us information about the grade for each of the pieces of the pipe. Um, so it depends on what the problem is, what you would do. So the grade, which is representing the slope. So one of the key things that you have to pay attention to is just to look at it and see how is the direction going. Okay, so with the direction, and since it's in a grade, so it's an incline, so that's dictates how it would be to find the numbers in front of I, J, and K. Now, for this particular problem, and let me go back to that one, the last slide. Like I said, like for this vector right here, okay, I could have wrote it in the simplest form in that it could have been 5 in I plus 1 in the K. Okay, I could write it in that form and it would have been fine. Now, trying to figure out where the numbers go, basically you got to think about the slope formula. So the slope formula is dealing with the change in y over the change in x. Okay, so we know that x is going to be associated here, but really in this case, this is one of the reasons why I was asking, if you look at it in terms of a 3D, which variables are being affected by this piece here. We notice that y is not being affected for the first piece, so that's why we ignore the j component. It was the z component or the k component that we were dealing with because of, if you look at how this is, we're going along x, but we also are going up on z. So z, this will be the coefficient on the z, this will be the coefficient on the x. And then we can think of the same way for this piece here. So for this other piece, and I can put like a dotted line here just to keep everything level. Okay, so on this piece, this would be representative of y, but you understand that you're going up higher on z. So that's why we have the j and k components here. And here's 1/10. This would be the change in k. This will represent the change in j. Okay, since we're dealing with that. Okay. Yeah, in this particular problem, the for the slope pieces, the rise portion is the z. Okay, so you got to think about it in terms of 3D. When you start rising, it's all actually being affected on the z-axis, not the x or y. And that's a great question, just to make sure that you understand how that works. All right. Any other questions? Okay, so that is it for today. So typically in class, we'll cover anywhere from 1.5 to 2 sections. The vector section was kind of short, so I went ahead and did the dot product section. So don't think that every class that we're going to cover 2, but we'll do at least 1 to 1.5. I mean, 1.5 to 2. Okay, it's typically what we'll do per class. So for homework, the two sections you're going to be looking at are for the vector homework and the dot product homework. Now, for the vector homework, I do have the solutions up there. The dot product homework, I'm in the process of working on putting those up there. So I should have those up there hopefully by tomorrow. I may have enough time before my next class starts at 1 to get those in there. So you'll have those and everything. Okay. Now, next week, you'll have your first quiz. Quiz 1 will come available. Okay. And typically the way the quizzes work is that the quiz will come available at the end of class and will be due by 11 a.m. before the next class start. Okay. For example, 2, yeah, you roughly get 2 days to take the quiz. Okay. Is it, for example, 2, was it from the section over vectors or the section over dot product? Okay, let's see here. This is why I put enough slides in here. It's dot product. It's that. Oops. Let me see something real quick. Dot product. Example 1, we did. Oh, okay. Yes, let me do example 2 real quick. I forgot which I actually have it in here in my face, but I just totally skipped over the problem, and that's my fault. Let me go through example 2 real quick. Okay. I do have it in my notes, but I kind of skipped over it. Sorry about that. I didn't go do the second example. So the second example for the dot product is this, and that's my fault. I kind of just glazed over my information, which I shouldn't have. So we're given that vector v is equal to -1 in the I direction plus 1 in the j direction. And then vector u is equal to the square root of 2 in the I direction plus the square root of 3 in the j direction plus 2 in the k direction. Okay, so for part A, we're going to find the dot product first. So if I do the dot product between these, I'm going to end up with negative square root of 2 plus the square root of 3. And that's the best I can do. The last component will be 0 because I don't have an I component. I don't have a k component in vector v. So it's going to be, is understood to be 0 times 2. Okay. Any questions there? All right, so the next piece, I want to find the magnitude of vector v. So that's going to be the square root of -1 squared plus 1 squared, or I'm going to end up with the square root of 2. Next is the magnitude of vector u. So that's going to be the square root of the square root of 2 squared plus the square root of 3 squared. So we're going to end up with the square root of 5. Oh, no, we're not. Sorry. Back up, back up, back up. I'm so wrong. Left out a little bit. Plus 2 squared. So we're going to end up with 3. It's much better. Okay, so the next piece, and I'm just going down order, but it should follow the order of that's in the notes. Next is to find the angle. So we should have that theta is going to be the cosine inverse of, we're going to have negative square root of 2 plus the square root of 3 over 3 times the square root of 2. And someone do that calculation real quick, and if you don't mind, give me the answer in both degrees and radians. Unfortunately, I don't have that written down, what the answer is. Okay, so 85.7 degrees. Okay, or 1.50 radians. All right, and then we still have 2 more pieces on it. Next is to find the that scalar. So that's the u dot v over the magnitude of vector v. So u dot v is negative square root of 2 plus the square root of 3. And then the magnitude of vector v, we said what's the square root of 2. And then the last thing we're going to do is to find the projection. Does everyone have all this down before I go to the next page? I don't want to rush. Okay, so let me go to the last page and do the last bit. And that's dealing with the projection. So we're going to do the projection of V onto U. So that's going to be the dot product of the 2 vectors over the magnitude of vector V squared times vector V. So we said that the dot product was negative square root of 2 plus the square root of 3 over the magnitude of vector v, which is the square root of 2, but we're going to square it, so it becomes 2. And we're going to take that multiplied by vector v, which is negative 1 in the I direction plus 1 in the j direction. And I'm going to go ahead and put the placeholder of 0 in the k direction, just so we see that it is you can write it as make it look like a 3D vector. Okay, and that will be the projection. Any questions? Sorry about skipping that, missing that problem out. I don't know what happened. All right. Any other questions? Okay, well, that is it for today. Again, the two sections that you'll have that you need to do the homework over is going to be vectors, the vector homework, and the dot product homework. Okay, um, and I will work on trying to get the solutions up for the dot products. Hopefully, I'll have them up by Friday morning. Okay, any questions, guys? All right. Well, you guys have a great rest of your weekend, and I will see you on Tuesday. Take care.